Hey, it's Steve. It's April 26, 2017. Time is 7:19. Temperature 64 degrees Fahrenheit out. And it looks like we're going to get some rain today. I was thinking, since people liked my sandstone video, I just think I'm going to do some videos on different rock types. And today I am going to do another type of sedimentary rock, carbonates. Carbonates consist of two main types, limestones and dolostones, and the metamorphic version is marble. Carbonate rocks are stable under metamorphic conditions, most metamorphic conditions. But I wanted to talk about carbonates because in the Paleozoic rocks, they form one of two ways. They're either a bunch of dead things packed upon one another, so they're biological in origin, or they are chemical in origin. You can precipitate carbonate rocks from seawater. We've done this in the lab. We observe it. Carbonate rocks, sandstones, carbonates, and shales together, those three rock types form what we call a typical marine sequence. Close to land, you tend to get your clastic sandstones. Then further out, you tend to get carbonate rocks, or you tend to get shales. Sorry, you tend to get shallow marine shales. Then you get your carbonate rocks. That's like the textbook example of a sedimentary sequence on a marine shelf. Doesn't always happen that way, but that's, like I said, the textbook answer. But anyway, carbonate rocks, we don't really get them older than 2.7 billion years old. We tend to get, during the Precambrian, we have a lot of what's called banded iron formations. The Earth doesn't make those anymore, and I'll get into that in another Geo-Rant. But about the time carbonates started to appear in the rock record, is about the same time we started to have free oxygen in the atmosphere. You see massive carbonates at like 2.5 billion years ago, which is also when modern plate tectonics began. And Precambrian carbonates, some of them, it's hard to tell because if they were formed by microorganisms, most Precambrian carbonates have been so deformed that, you can't tell. But many of them seem to be chemically precipitated. And they also seem to be more impure. Like you'll get calcareous sandstones, or you get sandy carbonate rocks. Okay. I was going somewhere with this, and I had it and I lost it. I know. Okay, so, and more modern limestones, like in the Silurian and stuff, they tend to be very pure. Now, under modern conditions, what happens is when you tend to get carbonate deposition, either from dead things piling up on one another or chemically precipitated from seawater, you tend not to get clastics within it. When I say clastics, I mean your sandstones and your mudstones. Okay, I'm talking about sedimentary rocks. It seems that as the environment needed to deposit carbonates, if you get an influx of clastics, that'll shut that system off. Now you do still have impure carbonate rocks. You will have silty or shaly limestones. You will have sandy dolostones. It does happen, but they're not as common as more pure limestones and dolostone rocks, at least from the Paleozoic, or at least during the Phanerozoic, let's say that. So that's my little Geo-Rant on carbonates, and I hope you learned something.